So once we've got the basics down of how to use multiplying the bases and dividing the bases and raising something to a power with exponents, we also are going to need to see what happens when we have negative exponents or even fraction exponents. And that's what that rational means. That's a fraction. So if you remember that squared and square root are inverses of each other, they undo each other, right? 5 squared is 5 times 5, it's 25. The way to go from 25 back to 5 is to take the square root of it. Those two undo each other. So we write that as the square root, but what we're really doing, that's a shortened way of writing to the power of 1/2. So square root of 25, we can also write that as 25 to the 1/2 power. Both of those mean the square root of 25. And notice what happens. If I had 5 squared, which I know is 25, but let's leave it as 5 squared for now, and I raised that to the 1/2 power, so I took the square root of that. The rule, right, for a power to a power is I multiply these exponents. So I say, what is half of 2? It's just 1. This is 5 to the 1, which is equal to 5. But let's think about this a different way, just with the numbers. 5 squared is 25, and then we're taking the square root of 25, we're back to 5. So just kind of two ways of thinking about why those are inverses of each other, why they undo each other. So now that we can write square root as to the 1/2 power, we can also write any root using those same fractional exponents, those rational exponents. So 27, the cube root of 27, we would just write as 27 to the 1/3 power. And what we're saying here is what number multiplied with itself 3 times gets you to 27. So since we can write 27 as 9 times 3, which we could write as 3 times 3 times 3. You can see I have 3 in there 3 times. The cube root of 27 is 3. And we'll do the same thing here with 81. This is really 81 to the 1/4 power, right? What multiplies with itself 4 times to give you 81? And this is 9 times 9, which I used 3 a lot, is 3 times 3 times 3 times 3. So we had 3 went in 4 times. The 4th root of 81 is 3. The reason for that is the inverse. 3 to the 4th is 81. So 81 to the 1/4 is 3. Okay, so how does that work then when we have a variable like x or y or z instead of a number? This guy right here is saying, first of all, I could just write this in exponents instead of roots. And then I could multiply those. I have x to the 5/3. But if I would like to really simplify this, I'm saying, what can I actually take out? How many x's do I really have here? So this guy, when we think about this cube root of x to the 5th, I have 5 x's in here. But we should know that anytime I've got, say, the cube root of x cubed, those undo each other. That is just x, right? So any group of 3 I have under a cube root can take 1x entirely out from under that radicand. So here, those 3 x's is an x cubed, and the cube root of x cubed is just x. So I'm going to bring all of those out. That's just an x. And then underneath, I still have that cube root of 2 x's left, x squared. This is my simplified form. I took out the x's that I could. here you can really see this same thing because x to the 5/3, you could think of 5/3, right, as 1 and 2/3. Here's my 1x, here's my 2/3, and to the 2/3 is the same as cube root x squared on the inside. So two different ways to get to this final answer. Okay, what if you have this mess? Y to the 4/5 times y to the 2/5. Since these both have fifths in that denominator of the fraction, these guys are both going to be under a fifth root. So really we have y to the 4th under a fifth root and y squared under a fifth root. So I really have 6 y's altogether under here. But instead of writing y to the 6th, I'm going to show you what I'm going to write instead. I'm going to just borrow a y over to here. Y to the 5th times, there's one more y left. And can you tell why I did that? This guy right here, the fifth root of y to the 5th, is just y. And then I still have a fifth root of 1y left. The other way you could do this is add these fractions together, y to the 6/5, and then you could use this same strategy to say that that is 1y and 1/5 of y, which is y times the fifth root of y. Two ways to get to that same answer. Okay, what about this? What can we do with that? Nothing really. However, you will see problems that say write this with exponents. Put it into a rational exponent form instead of a radical form. So all we're going to do is say that is a 1/5. And just in general, I'd like you to remember that x to the a over b power is the same as x to the a taken to the bth root. Now, looking at what happens with a negative power, something raised to the -1 is the reciprocal, or shout out to my friend Tony, miss you, the refliprocal. He came up with that in the 6th grade and it changed my life forever. It's the best. Because the reciprocal just means you're going to flip it upside down. So 3/4 to the -1 power just means we're going to flip it, 4/3. And 5 to the -1 power also means we're flipping it, but you might be saying, flipping what, Lindsay? It's just a 5. Well, any whole number can also be written as a fraction if you go over 1. So this guy to the -1 power means flip it, it's 1/5. Another way, since we're talking about inverses, to think about the reciprocal, the power of -1, is when you multiply a number with its reciprocal, it should equal 1. 5 times 1/5 equals 1. 3/4 times 4/3 is 12/12, which equals 1. So, of course, it's not just -1. We like to make your life hard. So we sometimes have a negative number that's not 1. So what this means is we're going to apply the power and flip it, or flip it and apply the power. And the order doesn't matter too much. Let's look at these both ways. First, let's do the negative. So first we flip it, and then we square it. Or let's square it first. 3 squared is 9 and 4 squared is 16. And then we flip it. Both of these work because I'm thinking of this as 3/4 to the 2 times -1. And I'm just choosing which one of those I want to do first. Do I want to do the -1 first and flip it, or do I want to square it first? So, same thing down here. We're going to, if we want, square it first, and then to the -1. Or flip it first, and then square it. What do you like? Your choice. So we're just going to do a couple practice problems here, You're just going to watch me, really, but please feel free to pause, try these on your own, come back when you're ready. So, in the first one, if I write this guy out in expanded form, I would have 5 y's up here, 3 y's down here. I can cancel, 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 and I've got 2 x's and 2 y's and nothing left on the bottom, or the multiplication version of nothing on the bottom. Here, I'm going to apply my exponent first, so I'm going to square the top. And then, since I'm dividing the bases on those x's, subtract the powers. No negatives yet. How sad. Here I'm dividing the bases. Let's subtract the powers to the -3. Ooh, don't leave it like that. We don't want to leave a negative in the final answer, so flip it. We also could have written this out in expanded form first. 1, 2, 3, 4, 5. Over here, I'm going to simplify inside the parentheses first because I can. Only 1b left on the bottom. And then apply that -1, flip everything upside down. Just as a side note, if you had subtracted that first, a4, and we have b to the -1, and then we applied that -1 power, we would have 1 over a to the 4, b to the -1. And then in order to have no negatives at the end of our problem, we have to flip any negative up to the other part of the fraction, to the top or to the bottom. So that's going to put b on top and keep that a down there. Down here I can multiply my coefficients together. And then since I am multiplying my bases, I'm going to add my powers. Here I am going to square everything first. And then flip it. So that gives me a 4x to the 4th down here times a 3x to the 4th up here. Oh my, cancel, cancel. This guy is just 3/4.